Hi everyone, Miss Barbara here with the first lesson in Algebra II Chapter 5, which is all about quadratic functions. Today we're going to be transforming the quadratic functions. You might remember from Chapter 1 that our parent function was y equals x to the second power. So it was a graph that looked like a parabola, a U shape. And now we're going to learn about different ways to transform it. The first one is a horizontal shift, which is a translation either left or right. So if you see something with a horizontal shift, you're going to see something with this, where x minus h, so your number will be in parentheses. In order to move something left, or your quadratic function left, in your equation, you're going to have a plus and a number. So in this case, we'll do plus 2. So this would mean left 2. So then quite literally on your graph, instead of being in the normal spot, it would be 2 to the left. So that's what a horizontal shift left looks like. Or horizontal shift right would be the opposite. So instead of plus a number, you would be doing minus a number. So to go right, you could have something like x minus 3. So this would mean you're translating 3 right. So your graph this time would be 3 to the right of where it normally would start at the origin. So for all horizontal shifts, it's the opposite of what you see in parentheses. So a positive 2 means left 2, a negative 3 means right 3. So this is always doing the opposite. So when it's in parentheses, you do the opposite. So that's horizontal shifts. For vertical shifts, it's the number that's being added or subtracted at the end, like this, plus k, and you do exactly what it says. So to go down, you would be subtracting 2. So if you wanted to go 2 down, it'd be x squared minus 2, and you'd be going 2 down. So from your original function, you'd be going down 2. And then to go up, you would add. So if you wanted to go up, you could do x squared plus 3, and you'd be going up 3. So that's how you transform horizontally or vertically. Next, we have reflections. So one way you can reflect is across the y-axis. This one doesn't pop up too much. To reflect across the y-axis, you might notice that your negative is in the parentheses. So they're in the parentheses. And what's weird about reflecting across the y-axis is, if your graph looks like this, when you reflect it, so I'm going to do this in highlighter, the left side becomes the right side and the right side becomes the left side. So your graph actually is not going to change if all you're doing is putting a negative on the inside of your parentheses. To reflect across the x-axis, which is what we do much more frequently, the negative is out in front. It's not in parentheses. So it's not going to be in those parentheses. And so those reflections now cause the graph to be upside down. Again, those are the reflections we see much more frequently. The last thing we can do, so we can move them left, right, up, down, reflect. And then the last thing is horizontal stretches, compressions, and vertical stretches and compressions. For horizontal, just like up here with horizontal shifts, everything that's in horizontal is going to end up being in parentheses. So notice my numbers are in parentheses here. For a horizontal stretch, you're going to have something as a fraction less than 1 in parentheses. So notice the 1/2 is in the parentheses. So a horizontal stretch is going to be really wide. So something really wide, wider than, I'll put the original in black. So this would be maybe what the parent function looks like, roughly. So the purple will be really wide. It's a horizontal stretch. So a compression, a horizontal compression, think of if you put your hands and you smush it together, it's going to get skinnier. So for example, I might have y equals, again, in parentheses, 3x squared, and it's going to be skinnier than your parent function. It was horizontally compressed. More frequently, we see vertical stretches and compressions. So I'll start again with my parent function in my picture. Vertical stretches are going to have a number not in parentheses. So a vertical stretch might be y equals 2x squared, something like that, and you're stretching it by a factor of 2. That says stretch. So to stretch something by a factor of 2, vertically, it's going to get skinnier. So then to compress, let's say, by a factor of 1/3, you might get something like this, and then it's going to be wider because you're compressing it. So it's not getting skinnier, it's getting fatter. So again, this is a compression by a factor of 1/3. So those are all of the transformations that we can have. And now we're just going to apply those in certain situations. So here in example 1, using the graph of f of x equals x squared as a guide, describe the transformations, then graph each function. Label each function on the graph. So here in number 1, I noticed 2 things. I noticed a -2 in parentheses and a +2 outside parentheses. Looking at my table on the first page here, doing -2 in parentheses means right 2. So I went right 2. Remember, it's opposite when it's in parentheses. So I did right 2. And then my green +2 means I went up 2. It's not in parentheses. So instead of starting at 0, 0, I'm now going right 2, up 2. So I'm going to start at this point. And then from there, it's going to be my parabola, my quadratic. So this is number 1 in blue. Now let's look at number 2. Number 2, I see 2 different things. I see a negative out in front, not in parentheses, and then I see this 3 in parentheses. So let's see what both of those mean. The negative not in parentheses, that's the reflection over the x-axis, so I know it's going to be upside down. So a reflection over x. The 3 in parentheses, well that, if you look above, is a horizontal compression. So for a horizontal compression, it's going to be skinnier than my original. So I'm not changing where I start. I'm still at 0, 0 for my vertex, but now it's going to be even skinnier than normal, and it's facing down because we reflected over the x-axis. You can also put this in your graphing calculator and see what it looks like. That's a great way to check your answer or to figure it out. Last one, number 3, all I see is the 1/2 in parentheses. So again, when it's in parentheses, that's a horizontal. This time it's going to be a horizontal stretch because it's a fraction less than 1. So a horizontal stretch means it's going to definitely be fatter than the original. I'll do this one in green. So it's going to be wider because it horizontally left and right got bigger. So that's our basic transformations. There's a special form called vertex form that shows the different transformations. So this is my vertex form, f of x equals a times x minus h plus k. Some basic transformations, if your a is positive, so again, your a here, that's out in front, we know that that shows vertical stretches or compressions. So whatever the number is for A will show a vertical stretch or compression. I'll just write S or C. If A is positive, we're going to be opening up. So it will look like a right side up U, meaning the bottom of my graph is going to have a minimum. If A is negative, I'm going to be opening down because I reflected across the x-axis. Remember, negatives out in front mean reflections across the x-axis. So I'm going to be opening down, and that's going to means I'm going to have a maximum here at the top. So that's what the A means. It shows vertical stretches and compressions, plus it's a reflection over the x if it's negative. Now I have an H and a K. So the H, when it's inside parentheses, remember that means you're going left or right, but it's the opposite. So you're going left if it's positive, right if it's negative. That's why there's a negative in front of H. That means opposite. And then the K just means up and down. So these are transformations in one form. The reason it's called vertex form is because this HK is actually the vertex. So it's really easy to graph if you know the vertex. My vertex is H, comma, K. So remember, it's actually opposite H because whatever is in your parentheses is the opposite of what H is going to be. So we'll see what that looks like. So HK, that is your vertex. So to graph things. So if you don't have a graphing calculator handy, we do need to know how to graph these by hand. So this is a way that you can graph these parabolas by hand. Step one is to find the axis of symmetry. So that's where your line is going to go through the vertex and it's going to be symmetrical on both sides. That is just the line x equals h. And remember, it's technically opposite h of whatever in your parentheses. And you can draw that line on your graph. Your vertex is going to be, as I said, hk. So it's right there in your equation. You don't even need to look for it. You're going to plot that point on your graph. You're going to make a table. You're going to put the vertex in the middle of your table. That makes it nice and easy to choose your points. So you're not just going to choose any points. You're going to choose x values immediately to the left and to the right of your vertex. So then that way we know we're getting the full picture, the full parabola in our graph. It should be symmetrical on the left and the right because of that axis of symmetry. Finally, we're going to plot, connect the dots and we'll get a U called a parabola. So example 2, graphing. So the axis of symmetry, I notice I have a -3 here and a -1. The axis of symmetry is going to be opposite h. Well, I have -3, so it's going to be +3. My vertex, therefore, is going to be +3, -1. So you do the opposite of the h inside the parentheses, and then exactly what you see for your k. So I'm going to put 3, -1 in my table, and I could go ahead and graph that right away. 1, 2, 3. So write 3 down 1. So this is my vertex. I want to choose points to the right and to the left of my vertex to make sure that I'm getting the complete picture. At this point, you can substitute in. So if you wanted to start with 1, you could substitute 1 in for x to get it. If you wanted to use your graphing calculator and go to the table function, so you would put your y equals x -3 quantity squared -1 in your graphing calculator and then press second table, which is graph. It'll give you these points too. So 1 is 3, so 1, 3 is a point. 2, 0 is a point. 4, 0 is a point. And 5, 3 is. Notice we have symmetry between my x is 1 and x is 5, you should have that symmetry, and between 0 and 0 for 2 and 4. So let's go ahead and graph the rest of these points. So I have 1, 3, 2, 0, 4, 0, and 5, 3. So my axis of symmetry goes through the vertex, and I can connect my points, and notice I get a parabola. Now it asks for my transformations. I see that I have two transformations. I went right 3 for my vertex, so I have right 3 and then down 1. That's all I did. There was no other compressions or stretches or reflections. So only transformations were right 3, down 1. Okay, so pause the video and try number 5 on your own. So where is your H? Where is your K? That's going to be your vertex. Can you make a table from those points? For number 5, notice I do have a negative out in front of parentheses. How is that going to change the way my graph looks? What kind of transformation is that? So pause the video, try this one on your own, and then check your work against the key. Number 6, we'll try number 6 together. Hopefully number 6 you're looking at and thinking, it's not in y equals yet. I still have this minus 4 on the left side I need to move over. Well, the inverse of minus 4 is plus 4, so this will become y equals 2 parentheses x plus 1 squared plus 4 at the end. So now I notice 3 things. I have a 2 out in front, and then I have a plus 1 on the inside of my parentheses and a plus 4 at the end. For the axis of symmetry, again, I just care about what's in parentheses, and I do the opposite. Well, I have x plus 1, so it's going to be x equals negative 1 for my h. So my vertex is going to be negative 1, comma, my k, which is 4 at the end. It's going to be a positive 4. So I'm going to fill in my table with x is negative 1, my y is 4, and then to the right of negative 1 would be 0 and 1. To the left would be negative 2 and negative 3. And now you can either substitute negative 3 in for x here in your equation to get your y's, or you can graph it and use your table. When you do that, you're going to get negative 3 is 12, negative 2 gives you an output of 6, 0 is 6, and 1 is 12. And again, I've got my symmetry between my y's, so 12 and 12, 6 and 6, 4 is my vertex. So now we can go ahead and graph that. I'm not going to, but you're more than welcome to on that graph. You might need to change your scale a little bit. I think if you went up by 2's instead, so 2, 4, and then negative 2, negative 4, that would be helpful. And then let's just quickly go through the transformations. There's 3 things I mentioned that we see. I have the 2 out in front. So the 2 out in front would be a vertical stretch of 2. So that would be a vertical stretch of 2. And then my vertex, or what's in yellow highlighted, would say I went left 1, which is opposite h, and then up 4, which is k. So those are my transformations. Now a couple of word problems. The parent function x squared is first reflected across the x-axis. So let's break this down. To reflect across the x-axis, if you look in the first page here, that means I have a negative out in front, no parentheses. So first I'm having equaling negative x squared. That's step 1. I reflected across the x-axis. Now, step 2. I horizontally stretched by a factor of 3. Again, if you look to the first page here, horizontal stretches by a factor of 3. A stretch means I have to have it as a number less than 1. So to stretch by a factor of 3, this would have to be 1 over 3 instead of the 1/2 that it is right here. So this is 1/2. We want it to be 3, so I'm going to make it 1/3 on my example. So step 2, I have to keep my negative from step 1, but now I'm going to put 1/3 in here with the square on the outside. And then number 3, third thing they want me to do. And then translate 2 down. Well, 2 down, I know I just have to minus 2 at the very end. So my final answer, which is going to be g of x, I'm going to keep all of this stuff I had before, so negative 1/3 x to the second power, and now minus 2 for 2 down. So those are the 3 different things in one function. Last question, a ball dropped from a tower can be modeled by the function h of t equals negative 9.8 t squared plus 400, where t is the time after the ball is dropped and h of t is the height at that time. A ball dropped from tower B can be modeled by the function negative 9.8 t squared plus 200. What transformation describes this change? What does that mean? So let's compare my 2 functions. I have negative 9.8 t squared plus 400 and negative 9.8 t squared plus 200. So the only thing that changed was the plus 400 to the plus 200. So that's a minus 200 change from 400 to 200. Means I'm dropping 200. So we're starting 200 lower than tower A. So we're starting 200 lower than tower A. That's a vertical translation. So that's vertical, going up and down. That is it for 5.1, translations and transformations of quadratics. We're going to find a new form of quadratics tomorrow in 5.2 that we're also going to be able to use to